This unit introduces you to textile printing and explains the print paste ingredients used in textile printing. The first module introduces you to textile printing. In the process of printing, color designs are developed on fabrics by printing with dyes and pigments in paste form with specially designed machines. Printing is used to apply colors only on localized areas according to the design pattern. Printed fabrics usually have clear-cut edges in the printed portions on the face of the fabric. Printing allows flexibility in creating variety of designs and enhance the aesthetic value of fabric. Let us now examine the differences between dyeing and printing. In dyeing, only monocolor application can be done, whereas in printing, mono or multicolor applications are possible. In dyeing, dyes are applied in liquid form, whereas in printing, dyes are applied with paste. Salt is needed for dyeing, but in printing it is not required. In dyeing, temperature is used for better penetration, but in printing, temperature is not being used. Water plays an important role in dyeing, but in printing, thickening agents plays an important role. In dyeing process, percentage of shade is calculated on the weight of the material, but in printing, percentage of shade is calculated on the weight of the paste. In dyeing, time is allowed for better penetration, whereas in printing, time is not required since color is applied only on the surface of the fabric. Off bleached fabric is used in dyeing, but full bleached fabric is used in printing. In dyeing, the fabric is handled either in open width or in rope form, but in printing, the fabric is handled only in open width form. During dyeing, the fabric may be wet or dry, but during printing, the fabric is to be kept in dry condition. During printing, color is applied uniformly on both faces of the fabric, but due to single printing, the printed face will be darker and other face will be paler. In dyeing, simple machinery such as tanks, winches, jiggers, soft flow and padding mangle are required, but for printing it is more complex by way of design, screen preparation, printing machineries and after process machineries. The cost of dyeing per meter is lower than cost of printing. The process of dyeing consumes more time than printing. Dyeing consumes more water than printing. For printing, the following are the general requirements of fabrics. The fabric should be stitched with proper face on top and uniform width. Shearing and cropping treatment is given to remove loose threads. Desizing is necessary for proper penetration of the print paste. Singeing removes hairy fibers to enable uniform adhesion of printing paste and sharpness. Scouring gives better dye absorption. Mercerization is given for cotton fabric and heat setting for synthetic fabrics. Full bleaching is suitable for whiter background. The fabric should be thoroughly dried. It should be free from creases and should be free from weft bowing. This module examines the ingredients of print paste. Let us now look at the thickeners and auxiliaries used in textile printing. In particular, we will look at dye stop or pigments, thickeners and auxiliaries used in textile printing, wetting agents, dispersing agents, anti-foaming agents, fixation accelerator, hydroscopic agents, oxidizing agents and reducing agents. Dye-stop or pigment. Dye-stop or pigment is used as coloring matter depending on the nature of the fiber. Lumps are broken using a wetting agent and smooth paste is obtained. Dye-stop or pigment is selected on the basis of cost, fastness properties and requirement of shade. Thickeners and auxiliaries used in textile printing prevents the spreading of the color on the cloth by capillary action. The choice of thickener depends upon the class of dye to be printed and styles of printing. For example, CMC, Indulga, Terraconth, British gum, sodium alginate, emulsion thickener, etc. Wetting agents are used to obtain a smooth paste of the dye-stop without formation of any lumps. Lumps, if allowed to remain, get deposited on the cloth during printing and produce dark spots. For insoluble dye-stops like wax and naphthals, wetting agents are used to facilitate wetting of the dye-stop. For direct, acid, basic and reactive dyes which are water soluble, a wetting agent is normally not required. Dispersing agents are used to prevent precipitation of dye particles as the concentration of the dye-stop in the printing paste is high. For example, diethylene glycol, thiodiglycol, sodium benzyl sulfonylate. Anti-foaming agents are used to reduce frothing in the printing paste. Dye-stops have a tendency to froth during color preparation and printing because of the presence of wetting agents and continuous agitation by the printing roller and brush finisher. Due to frothing, the paste overflows on the floor or onto other color box. The print also becomes specky and lighter in shade. Fixation accelerators are used to improve dye-stop fixation in printing as well as to shorten fixation time. They are also effective in preventing fixation unevenness that may be caused by fluctuation of conditions for dye-stop fixation such as temperature, time and humidity, etc. The examples are p-phenyl phenol is applied for polyester, thiourea is applied for polyamide, resorcinol is applied for polyamide, cotton and acrylic fibers. Hydroscopic agents are used to take up sufficient amount of water during steaming. This gives mobility to the dye molecules to enable them to transfer into the fiber. Examples are urea, glycerin, diethylene glycol. Oxidizing agents are required for printing certain classes of dyes and also in discharge and resist printing. Most commonly used oxidizing agents are chlorates, chromates and dichromates, nitrates and nitrites of sodium, potassium ferrocyanide. Reducing agents are required for discharge and resist printing as discharge chemicals. Examples are sodium sulfoxylate formaldehyde, zinc sulfoxylate formaldehyde, potassium sulfite, ferrous sulfate, stannous chloride, thiourea, etc. Essential properties of thickeners for printing. To meet all the requirements for printing, more than 2 selected thickeners are used. For better workability, the following are considered while choosing the thickener. Quick drying. It should have desired viscosity, flow, ability to wet and good adhesion to substrate. It should not affect the shade of the dyes used. The storage stability of thickener should be good. It should have low foaming properties. It should be compatible and inert to dyes and other ingredients for the printing paste. It should have good elasticity during squeezy action. It should have good film strength and non-cracking after drying. It should have thermal stability at higher temperature. It should be easily washed out, should be available at a reasonable price and should be biodegradable and eco-friendly. Advantages of synthetic thickeners. Synthetic thickeners are derived from suitable vinyl compounds. They provide finer designs with fine screen gauge and roller engravings, are cheaper and ecologically beneficial, enhance dye fixation and helps to achieve greater depth of color, require no special storage requirements. Synthetic thickeners when used without solvent produce very high quality of pigment prints. They are free from hardening, browning during high temperature fixation. You have come to the end of this unit. To summarize, in this unit you have been introduced to textile printing and the various ingredients used in print paste. Thank you.